Welcome to yet another video on SRID Cloud. In this video, I want to do something different and also should be very useful for anybody who is starting on understanding computer networking for students and so on. So in this video, I want to show you how computers on two different networks can talk to each other. What are you supposed to do to make that happen? It's not going to be very complicated at all. It's going to be very, very simple. So let's get started. So here is what I have. The San Francisco network and New York network. And they are connected midway somewhere in Chicago. So what does it mean? There are three computers in the San Francisco network. They are connected to each other. And the 192.168.40.0 is what is called the network ID of that network. And similarly, on the New York side, there are three computers and they are connected together. And the network on New York is 192.168.30 network. That is the network ID. And if you noticed, the San Francisco 1 and San Francisco 2 computers have only one network interface on them. But on the San Francisco gateway, there are two network interfaces. One is connected to the internal San Francisco network. The other one is going to Chicago. Just imagine there's a wire running from San Francisco to Chicago. Somehow they are connected. And what is in Chicago is what is called an Ethernet switch. And that switch has multiple ports on it, and one of the port is occupied by the wire coming from San Francisco. And similarly on the New York 1 and 2 are the computers having only one network interface on them each. But the New York gateway has two network interfaces, one connected to the internal network, the other one is connected to Chicago. So the idea is to not only let the computers talk to each other on either of the networks, but also talk across. Say for example, I'm going to show you how to connect San Francisco 2 talking to New York 2 or New York 1. Or New York 2 talking to San Francisco 1, and so on. So what are you supposed to do to make this happen? That is exactly what we are going to see now. So now let's go to each of these computers and see how the networking is configured on them. So let me switch over to New York first. So I am in New York 0 computer right now, and let me see what are the network interfaces running on it or connected to it. IPA is the command, and you can ignore the first one. There is a link loop back. The other two, the ENS33 and ENS38, are the two network interfaces connected to the New York 0 computer. One carries the 192.168.40 address. In this case, it is 192.168.40.135. And the other one is connected to the 30 network, the 192.168.30.133. And then let us look at the route. There's a command called IP route. And this output has three entries in it. You can ignore the first one. The second and third are pointing to the routes. So if this computer wants to talk to anything on 192.168.30 network, which is New York network, the local network, then it has to go through the ENS38 interface. And if this computer wants to talk to anything on 192.168.40 network, which is the San Francisco network, then it has to go through the ENS33 interface. And ENS33 is the one that is connected to Chicago. And ENS38 is connected to the local network. So now let's go to San Francisco 0. We should see something similar there. There are two network interfaces, ENS33 and ENS38. The first one is connected to the 40 network, which is San Francisco network. 192.168.40.132 is the IP address. And the other interface is connected to the New York network. That is 192.168.30.132 is the IP address. ENS38 is the one that is connected to Chicago. And ENS33 is the one that is connected locally inside the San Francisco. So now let's look at the other four computers and how they are configured. Let us go to New York 1. There is only one network interface on it. Its IP address is 192.168.30.134 because New York is a 30 network. And let's look at the route. There is only one route in it. That means this computer can talk to any other computer on the New York network only. There is no mention of 192.168.40 network here at all. So this computer cannot talk to anything on the San Francisco side. It can talk only to the other computers on the New York side only. If you don't understand what I mean by this, I think you will understand by the time you complete watching this video. So now let's go to New York 2 and see how that is configured. As expected, this also has only one network interface on it, 192.168.30.135. And let's look at the routing table. This one has got something different. Compared to New York 1, this has got an extra entry in the IP route, and that is 192.168.40 network is connected. And the route rule says 192.168.40 network is connected through the 192.168.30.133. So what exactly is this 133? It is another computer on the New York network, and it is called New York Gateway. And this is the computer that has two network interfaces on it. One connected locally to the New York side, and other connected to Chicago, or connected to San Francisco via Chicago. So what does this rule mean? If this computer wants to talk to a computer, so this computer is a New York network, and if this computer wants to talk to anything on the San Francisco side, then the San Francisco network IP addresses are all 40 IP addresses. So the moment you any application running on this computer tries to talk to a computer on San Francisco side, which is 192.168.40, then those packets will be sent to the New York Gateway. And New York Gateway IP address is 192.168.30.133. So the New York Gateway will receive such a packet, and it will realize that it does not belong to New York. It belongs to San Francisco. So then it will send the entries, the bits, to Chicago, and through Chicago the bits will go to San Francisco. That's what this rule means. So now let's take a look at the San Francisco 1 and 2 as well. So this is San Francisco 1. As expected, there is only one network interface on it, and then the route has got that extra entry in it. This is the 40 network. The San Francisco is on the 40 network, but there is an entry on this computer for 30 network. So if this computer wants to talk to New York, then it has to go through this 192.168.40.132, which is the San Francisco Gateway. and the San Francisco gateway will receive such a packet, and it will realize that the packet does not belong to San Francisco, so it will send it across to Chicago, and from Chicago it will reach New York. So now let's look at the San Francisco 2 computer. So there's only one network interface on it, and IP route shows only one entry in it. There is no mention of 192.168.30 network at all in this IP route. What does it mean? That this computer, San Francisco 2, will be able to talk only within the network, the local network on San Francisco, but will not be able to talk to anything on the New York gateway or New York network, because there is a missing routing table entry in it. So now let's talk about how the San Francisco gateway and the New York gateway are able to talk across the networks. So to enable this on New York gateway and then San Francisco gateway, you need to do something called IP forwarding. So let's see how that is done. So let's go to the New York gateway, and I'm going to use the history command. So this is the command that you should run to enable IP forwarding on this gateway computer. Sudo sysctl -w net.ipv4.ip_forward equal to 1, and then you are supposed to load the changes using sudo sysctl -p. So the moment this is done, any computer that is talking to New York gateway will be able to talk either locally or across the networks. Similarly, in the San Francisco 0 network, which is the San Francisco gateway, the same commands were executed on this as well. So the IP forwarding is very, very important on these machines, and you don't have to do the IP forwarding on the other San Francisco 0 or 1 or New York 1 or New York 2 computers. You can do it only on the gateway computers that have multiple network interfaces on them. So any packet that is coming in from, say, San Francisco 0 will be received by San Francisco gateway, and if that packet is meant for New York, then due to this IP forwarding, those packets will be sent or forwarded to the other network interface on it. Similarly on the New York side. So now let's do some pinging. So let's go to New York 1, and let me ping another computer on the New York network. So this is New York 1, and its IP address is 192.168.134. So let me ping the other IP address, 192.168.30 and 135, for example. So it's able to ping the other computer on the same network. But what about across the network? So as we saw earlier, the route has no entries at all for San Francisco. So even if I do ping 192.168.40 dot, say 133, this will not work, because the networking on this computer does not even know what exactly is 192.168.40 network at all, because there is no route for 40 network in this computer. But let's go to New York 2, where we had such a route, and let me ping any San Francisco IP address, which is 192.168.40.133. It works. But this does not mean that the IP forwarding is the only method to talk across the networks. On the receiving end also, there is supposed to be an IP route to talk back. So in this case, we try to communicate to 192.168.40.133, which is San Francisco 1 machine. So here it is. And if I look at the IP route, I see an entry to talk back to 30 network. Without this particular entry, whatever we tried to do earlier, this ping would not work. So the IP route has to be present on both sides to talk across the network. So to summarize, this is how you can set up the networking on computers on either networks, subnets actually. And here, this is how you enable the IP forwarding on the gateway computers, one on each on the networks. And this is how you design the IP routing table in such a way that the computers or the applications running on them knows where to talk to and how to talk to. I hope you enjoyed this video and learned a little bit on IP forwarding and then IP routes and other networking concepts. And I will try to produce more videos in near future. And have a wonderful day, and bye for now.